Okay, folks, now we enter the world of rocks that form at the surface of the Earth. These are called sedimentary rocks. Now, sedimentary rocks form over millions of years. Sedimentary rocks form from sediment that was deposited in a basin and then buried by more and more layers of sediment until all of those grains are compressed and cemented together, forming a massive continuous rock unit. Now, you can imagine it takes a long time to grind a big rock into smaller pieces, and then even longer for them to go from the original rock to a basin, and then even longer time for them to form into rocks through burial processes. So, step one in the journey to becoming a sedimentary rock is called weathering. This is the fancy geology word for chunks of rock falling and breaking off of a bigger, larger rock. Usually freshly weathered material will be all kinds of sizes, from boulders as big as cars down to dust. But the thing that all of these bits and pieces all have in common is that they're jagged and angular. Now, step two in the process is called erosion, which is the fancy geology word for saying this bit of rock has been carried away from that bigger chunk of rock that it came from. Okay, the further away that a bit of rock goes, the more it's bounced around by gravity or wind or water, and the rounder and more polished it becomes. So when we're looking at a rock made up of chunks of other rocks, well, that can tell you a lot about where that rock formed. You don't believe me yet? Well, hold on and give me another minute of your time. Okay. So the places where sedimentary rocks form are those basins where all of that sediment collects and then becomes buried. Now we call those sedimentary basins. There are lots of different kinds of sedimentary basins, and I mean a lot, like enough to fill an entire semester-length class. But in this class, we're really only going to be looking at a tiny few of them. Now, in general, I want you to know that there are terrestrial depositional basins on land, marine depositional basins in the oceans, and marginal deposition basins in the sort of in-between places. So let's take a look at a few of these depositional environments and see if we can identify the evidence of the environment in the rocks that they form. Okay, so first, Breccia, my favorite rocks to make puns with. As you can see, the clasts within Breccia are large and sharp. They form in buried debris flows like landslides in the mountains or at the beginnings of very fast-flowing alpine rivers. Now, for the most part, breccias form very close to the rock that they broke off from, and they're not changed very much. Okay, does that make sense for a scree field, say at the base of a peak, and then it was buried and became a rock to form Breccia? You Breccia, absolutely. Do you see how there is evidence in this rock that showed us exactly where this rock formed? I hope so. But just in case, let's take a look at a few other examples. Okay, this is called a conglomerate. It has largish, mostly rounded clasts, which is that fancy word that we use for rocks in a rock. Now, if you squint and imagine a larger rock unit that would be this conglomerate, can you see a riverbed? Now, many geologists can, which is good because that's exactly where conglomerates form. Now, there are all sizes of cobbles and pebbles in a river and mud to cover them. Can you kind of see that now? Okay, but what if we look at this sandstone, another sedimentary rock? Well, where do we commonly find sand? Beaches and deserts, right? Well, perfect, because that is exactly where sandstone forms. When the sand at a beach or in the shallows near a beach or in a desert are buried by fresh sand and then buried and buried and buried and buried and buried ad nauseum, eventually it becomes sandstone. And you can see all of those beautiful layers of sand in the sandstone. Okay, let's try another one. Okay, this is shale. Now, can you see all those tiny muddy clay particles? Well, not really, right? But that's okay because they're so small. But what if I told you that shale is made up of mud? Okay, so where do you think this rock could have formed? A swamp? A lake? A river delta? All definitely possible. Look at you, you're a pro. Now, shale and clay rocks are also very cool, not just because they're made of mud, but because they are super fine-grained and they cover everything, and they form a hard protective shell. So if you've ever worked with pottery, you probably know exactly what I'm talking about. And because of this, shale is super good at preserving fossils, even chemical fossils, which is pretty cool for plain old mudstone, right? Okay, well, that's it for now. I hope you can see that there is a wide range of information locked into these rocks. And so even though they might be a bit plain and are pretty common, they're also very special, especially to a paleontologist like me. So I hope that you've been able to see that sedimentary rocks can hold a lot of information about the place that formed them.